Hi, and welcome back to Weekly Dev Tips. I'm your host, Steve Smith, aka Ardalis. This is episode 62 on the nature of mapping requirements to our software design and architecture and how we deal with change. This week's tip is brought to you by devBetter.com. What is devBetter? It's a private group coaching community geared toward accelerating developer careers. We meet weekly for live Q&A sessions and have an active Discord-based discussion the rest of the week. Topics range from coding skills to interviewing and personal branding. Check out devbetter.com and read the testimonials at the bottom of the page to see if it might be right for you. This week's guest is Juval Löwy of iDesign. He has a tip for us this week on how we approach writing software. I'll let him introduce himself and share his tips.
Hello, my name is Juval Löwy. I'm the principal architect at iDesign. I'm also a speaker. I conduct masterclasses all over the world and an author. My recent book is called Writing Software by Edison Wesley, and it was just published this week. My tip to you today is about change. But before we get to change, I want to talk about how developers actually write code. Most developers, when they write code, try and maximize their adherence to the requirements, what the system is required to do. And they go into great detail into transcribing it into individual tasks, and that can be directly mapped into code artifacts, be it methods or sometimes individual classes or services. Well, I think that's actually wrong. And there's several reasons why it's wrong. At the very least, you're not going to have just 1, 2, or 3 things to do. You could have hundreds of things to do. And if the way you actually break down the code is based on the functionality, you will always end up with an explosion of little things. And that's obviously a very difficult design because you have to integrate all of those things. That's very expensive. The alternative is taking classes or services and just dumping everything into them, all the functionalities. And you get these ugly dumping ground, these monoliths of doom with insane level of internal complexity. In addition, somebody in that system has to actually perform those functionalities, and that somebody is typically the client. As a result, the client is actually polluted with business logic because all the orchestration of those functionalities now reside inside the client. Now, the real reason why this kind of functional decomposition is bad is because of change. If you try and maximize your adherence to the requirements, the problem is that requirements always change. First of all, nobody ever gives you the right requirements. Users have the wrong understanding of what the system is supposed to do. Often, customers don't understand their own business. So whatever they give you is actually quite questionable. Users and customers and marketing people often miss requirements, or they have duplicate requirements, or they have mutually exclusive requirements. Any attempt of designing against that guarantees that when those requirements change, your design will have to change. But even if they give you perfect requirements on day one of the project, which by the way nobody ever does, even that will be no good because over time those so-called perfect requirements will change. Change is inevitable. And in fact, change is actually very good because the change keeps all of us employed. If requirements were not dynamic, then none of us would actually have a job. Now, when you design against the requirements, you actually guarantee that your design is going to change because of the change in the requirements. And actually, nothing is more painful in a software system than a change in a design. And many developers have seen it firsthand, and they may call it things like technical debt, but nobody ever asked, why do we end up with this technical debt in so many systems? I think the fundamental reason is what I just said. It's the attempt of designing against the requirements and not taking into account that the requirements will change. The way to solve it is actually not to design against the requirements. And it now sounds like heterodoxy, but that's the first thing to recognize. You should never design against the requirements. What I find is that the best way of designing a software system is to identify areas of potential change, or what we call at iDesign areas of volatility. Then what you do, you encapsulate those areas of volatility in components of the system, be it classes or services or module. And then you implement the required behavior as the interaction between these areas of encapsulated volatility. And we call this approach volatility-based decomposition because you designed based on the volatility, not based on the functionality. Now, in most systems, you're going to have not one or two areas of functionality, but your own areas of volatility, but you're also not going to have 100. You're going to have about 10 or a dozen areas of volatility. Now, what's nice about that particular number is, remember how I said you're supposed to provide the required functionality. You're supposed to provide it by integrating areas of volatility. Now, even with about a dozen components in your system, there's an absolute staggering number of possible combinations. It's closer to n to the power of n more than anything else. And now what you have is you have infinite ways of putting those components together. And therefore, a relatively small set of well-encapsulated areas of volatility is capable of providing a near limitless number of interactions and therefore functionalities. And it turns out what I just said is a universal observation about the nature of things. For example, I'm recording this podcast right now by integrating areas of volatility. The laptop I'm using right now is unlike the laptop you're using. And the internal components of the laptop are completely different than your laptop. And nonetheless, all of that volatility is encapsulated behind the keyboard or the mouse or the network jack of the laptop. I would not be able to conduct this podcast if I took care about the intricacies and the way the functionality of the laptop actually works. Now, the nice thing about volatility-based decomposition is that when a change happens, it is actually contained. If what you truly did is volatility-based decomposition, then every change has a box. And so you start thinking about your architecture as a series of vaults. Each vault encapsulates an area of potentially very dangerous change. When a change happens, it's like a hand grenade. It's very dangerous. You open up the door of the appropriate vault, you toss the hand grenade inside, and you close the vault. Now, whatever was inside the vault is completely destroyed, but there's no sharpener flying all over the place. You have contained the change. Now, if you compare that with what I said initially, which is designing against the requirements, if you design against the requirements, if the very breakdown of your system to its constituent components is based on functionality, now you can call those things domains. It doesn't really matter. You're actually decomposing based on functionality. Then when a change happens, it's by definition not in any one place, because you decompose based on functionality, based on requirements, not based on change. So the change is by definition not in any one place. So now when a change happens, it's fundamentally a very good thing. It is like swallowing a live hand grenade, and the sharpnel is flying and basically destroying the system. And most developers have seen this firsthand as they try and integrate a change, and it's a massive sweeping change that affects everything in the system. Well, that's basically because they did not encapsulate the change. You have functional decomposition. But there's another benefit for it. If all the components are actually encapsulated, then fundamentally when a change happens, you contain it, and then very quickly you respond to changes in the business place, in the environment, in the requirements. Now, the ability to quickly respond to changes in requirements by actually minimizing the impact of your system is the very essence of agility. Now, what I said so far about volatility-based decomposition is fairly abstract. Fortunately, we don't design or build houses or laptops or airplanes. Most software developers develop software systems. And so you can actually recognize common recurring areas of volatility in software systems. And if there's common areas of volatility, you can also recognize common interactions and do's and don't and relationships and even structure. And if you recognize that, you have a very quick way of actually going about doing the system design. So just to recap, you should really design your system based on change and not based on functionality. For more on this concept, let me refer you to Writing Software, published this week by Edison Wesley.
Thanks, Juval. I've included a link to Juval's book, Writing Software, that's Rightting, in the show notes. Juval was kind enough to send me a copy, and what I've read so far makes a lot of sense. That's it for this week. If you want to hear more from me, go to rdallas.com/tips to sign up for a free tip in your inbox every Wednesday. I also try to stream on Fridays, noon Eastern Time until about 2 p.m. Thanks for subscribing to Weekly Dev Tips, and I'll see you next week with another great developer tip.